Okay, we've been talking about heat expansion, and I want to talk about what does water do when you heat it up. So we're going to start off with water as a solid, which is ice. And so in the picture there on the left, it shows some water molecules that are all locked together to make solid water, which is ice. And so you notice that it makes a hexagonal pattern. So if you've ever looked at a snowflake, it has six sides to it. And that's because on the atomic level, this is the way that the molecules of water are hooked together. So each one of these dots is a water molecule, and water is H2O. So it's going to have an oxygen, and then it's going to have two hydrogens that are going to be coming off of it. And then the same thing for each one of these. And then they hook together to make this solid here. And notice it's got this big empty space in the middle. Now it's not like there's air in here, it's just that it's empty. And so that means that when water is in the form of a solid, it has more volume than when it's a liquid. So on the right hand side, you see that as we increase the temperature, then what happens is that the springs that are holding these molecules together are getting stretched more and more until they finally break. They have so much energy that they break. And so this thing collapses to a water, liquid water, and so everything has all collapsed together. So notice this has a larger volume than what this does. Okay, then what's our definition of density? So density is given by the letter rho, and it's going to be equal to the mass of an object divided by its volume. So if you've got a large volume, you have a small density. If you have a small volume, you have a large density. So because this has the large volume, it's got the small density, and that means that its density when it's a solid is going to be less than its density when it's a liquid, so that ice floats on top of water. So in that graph there, you have density going up and down, and then you got the temperature going sideways. So we're going to start at 0 degrees Celsius, and you see that the ice is going to have a certain density. As we increase the temperature, notice that the density is increasing because the ice is collapsing into that liquid form. So when it becomes a liquid, it's going to have its maximum density, and that corresponds to about 4 degrees Celsius. Now, if we continue to increase the temperature, then the liquid water is going to be vibrating, and so its volume is going to start to expand as usual. And so now notice as the volume is expanding, then the density is now going back down again, so that the blue line at first goes up as it's melting, and once it's all collapsed, then it starts to expand again, and then the density begins to go back down again. So this has huge consequences as far as lakes and the ability for fish to live in cold weather. So let's take a look at this picture here. So that shows a pond, and what we're going to do is let's say it's winter time out. So we're going to start to decrease the temperature above the lake, and so that's going to start to cause the temperature of the lake to go down. Now, during the wintertime, the outdoor temperature may drop below 0 degrees Celsius, which is going to be cooling the water in the lake. But when the temperature of the water reaches 4 degrees, So the temperature, let's say, starts out at 10 degrees Celsius. And then above it, you got this cold air. And now the temperature goes down to 9, and then to 8, and then to 7, and then to 6, and then to 5. But once it gets to 4, notice that it has its maximum density. So if we go back to here, maximum density is going to occur at 4 degrees Celsius. So what will happen is that cold water is going to sink to the bottom of the lake. So that means that the water that's at the top of the lake now the temperature maybe is back up to 10 degrees Celsius because all of that cold water has gone down to the bottom of the lake. So that means now that the temperature of the water at the top of the lake has to be cooled down again, but once it reaches that 4 degrees, and once again it's going to drop to the bottom of the lake. So that means that the only way to get that lake to freeze is if the temperature is all the way from the bottom of the lake all the way up to the top of the lake is at 4 degrees. So now the whole lake is at that temperature of 4 degrees. Now, whenever you lower the temperature of the lake, once it reaches 4, it can start to go down even further. And eventually it can reach 0 degrees Celsius. And then when it reaches 0 degrees Celsius, the top part of the lake can freeze over. So notice that this will keep a lake from freezing prematurely. And also, the ice on the top is going to act like a barrier to keep the water underneath it warmer. And so this means that the fish will be able to live underneath the ice in this lake. All right, so let's take a break, and when we come back, we're going to talk about heat storage in materials.